Could the answer to the age-old question, "Are we alone in the universe?" be floating high above the surface of Jupiter? Imagine, not in a faraway galaxy or another dimension, but right here in our solar system, within the massive, swirling, cloud-covered world of the King of Planets. The idea might sound like science fiction, but groundbreaking theories are suggesting something astonishing. Jupiter's clouds could hold the key to extraterrestrial life. Let's start by picturing Jupiter, a planet so massive it could fit over 1,300 Earths inside it. Its iconic Great Red Spot, a storm larger than our entire planet, has been raging for centuries. Its colors, swirling patterns, and sheer size make it one of the most captivating objects in the night sky. But beneath all this turbulent beauty lies an intense and extreme environment, one that most scientists believed was utterly inhospitable to life. Yet, as we've ventured deeper into the mysteries of our solar system, we've learned that life often finds a way in the unlikeliest places. Here on Earth, life has been discovered thriving in boiling hydrothermal vents, acidic hot springs, and even radioactive waste. So, if life can endure such conditions here, could it also exist 300 million miles away in the turbulent skies of Jupiter? Unlike its rocky neighbors, Jupiter is a gas giant, meaning it doesn't have a solid surface. Its atmosphere is a complex mix of hydrogen, helium, and trace amounts of other chemicals, with clouds composed primarily of ammonia and water vapor. But somewhere within those clouds, between the planet's crushing depths and freezing outer layers, lies a sweet spot, a region with temperatures and pressures that might just allow for life as we don't yet fully understand it. What makes this idea even more fascinating is that these potential conditions aren't unique to Jupiter alone. Planets like Venus and Saturn's moon Titan have sparked similar speculations about life in their atmospheres. But today, we're focusing on Jupiter, the largest and most enigmatic planet in our cosmic backyard, and asking a daring question. Could life already be thriving there, unseen and untouched by human exploration? Before we dive deeper into Jupiter's skies, uncovering the shocking possibilities of alien life, make sure to hit that subscribe button and tap the notification bell. You won't want to miss future cosmic journeys as we explore the mysteries of our universe, because the answers may be closer than you think. At first glance, Jupiter seems like the last place you'd expect to find life. It's a gas giant with no solid surface. Its winds howl at speeds exceeding 300 miles per hour, and its radiation belts are so intense that they could fry a spacecraft in mere moments. But even in these extreme conditions, scientists have found a surprising reason to consider Jupiter's clouds as a potential home for alien life. Let's break it down layer by layer. The first clue lies in Jupiter's complex atmosphere, which is composed primarily of hydrogen and helium, with traces of ammonia, methane, and water vapor. This composition might not scream habitable at first glance, but deeper analysis reveals intriguing possibilities. Jupiter's atmosphere is structured in distinct layers, each with its own temperature, pressure, and chemical makeup. In the upper layers, the temperatures drop to frigid extremes, while the lower layers are subjected to crushing pressures and scorching heat. However, between these two extremes lies a middle layer, what scientists often call a habitable zone. In this zone, temperatures range between 10 degrees and 40 degrees, 14 degrees to 104 degrees, similar to conditions we see in Earth's troposphere. What's more, traces of water vapor have been detected within Jupiter's clouds, and water, as we know, is a fundamental building block for life. Imagine a region in Jupiter's skies where droplets of water mix with ammonia and other compounds, creating an environment not too dissimilar to the clouds on Earth. Could life have adapted to survive here? Microbial life on our own planet has been found thriving in airborne ecosystems, floating through clouds high above the Earth's surface. If life can survive in Earth's atmosphere, why not in Jupiter's? But even if Jupiter's clouds have the right temperatures and water vapor, life also needs energy to thrive. So, where could it come from in such an alien environment? Jupiter's storms might provide the answer. The planet is famous for its colossal lightning storms, which are far more powerful than anything we see on Earth. These lightning strikes can trigger complex chemical reactions in the atmosphere, producing a variety of organic molecules that could potentially serve as the building blocks of life. Another energy source comes in the form of ultraviolet, UV, radiation from the sun. While UV radiation can be harmful to life as we know it, it can also play a crucial role in sparking chemical reactions that lead to the formation of organic compounds. Combined with the swirling winds and dynamic weather systems of Jupiter's atmosphere, these processes could create a dynamic environment where life might find a way to survive. To understand how life might survive in such a setting, we don't have to look far. Earth's atmosphere provides some incredible analogs. Here on our own planet, scientists have discovered microorganisms living in some of the most extreme environments imaginable. For instance, cloud microbes. Bacteria and fungi have been found floating in Earth's clouds, enduring freezing temperatures, low oxygen levels, and high UV radiation. These airborne microbes can remain suspended for days or weeks, feeding on nutrients found in water droplets. Extremophiles. Organisms like acidophiles and thermophiles thrive in highly acidic or scorching environments, conditions that might mirror some of Jupiter's atmospheric layers. What makes these discoveries so exciting is that they challenge our assumptions about where life can exist. If microbes can float in Earth's skies, feeding on minuscule resources in water droplets, it's not entirely implausible that similar life forms could drift through the clouds of Jupiter, perhaps metabolizing ammonia or other compounds as a source of energy. So, we've seen how Jupiter's atmosphere offers a mix of water vapor, potential energy sources, and a habitable zone. But there's still one big question to answer. What would life in such a place actually look like? In the next segment, we'll dive into the groundbreaking discoveries and the mind-blowing possibilities of what might be floating through Jupiter's skies. While the idea of life drifting in the clouds of Jupiter is thrilling, the reality of its atmospheric conditions poses some monumental challenges. This isn't just a place of swirling beauty. It's an environment shaped by extremes of pressure, radiation, and chemistry. If life exists here, it would have to be unlike anything we've ever seen. Let's take a closer look at these challenges and what they mean for the possibility of life. The first obstacle is the sheer hostility of Jupiter's environment. As you descend into the planet's atmosphere, the pressure increases dramatically. At the topmost layers, the pressure is similar to what we experience on Earth's surface, but go deeper, and it becomes crushing, eventually exceeding millions of times the atmospheric pressure on Earth. Anything that ventures too far down would be obliterated by this immense force. Adding to this, Jupiter's atmosphere is bombarded by intense radiation from its powerful magnetosphere. This radiation belt, created by the planet's magnetic field, is thousands of times stronger than Earth's and extends far into space. It's so severe that it can destroy electronics on spacecraft, let alone any fragile, unprotected life form. And then there's the lack of a solid surface. Jupiter doesn't have land as we know it. No mountains, no oceans, no ground to anchor life. Any organisms that might exist here would have to live entirely within the dynamic and unpredictable atmosphere, potentially riding on turbulent winds and weather systems. The chemical makeup of Jupiter's atmosphere poses another significant challenge. Hydrogen and helium dominate, accounting for more than 99% of the atmosphere. While these elements are abundant in the universe, they don't provide the kind of raw materials that Earth-based life depends on. Life on Earth is carbon-based, relying on a variety of organic compounds to build cells, replicate, and carry out metabolism. But in Jupiter's atmosphere, carbon-based compounds are relatively scarce. Instead, the clouds are saturated with ammonia, which is highly toxic to most forms of life we know. These ammonia clouds are also highly acidic, creating an environment that could easily break down or dissolve any fragile biological structures. Scientists have speculated that if life exists in Jupiter's clouds, it might not be carbon-based at all. Instead, it could rely on entirely different chemical pathways, perhaps even silicon-based life forms, or something we can't yet imagine. Finally, we have to consider the impact of Jupiter's immense gravity. With a gravitational pull more than 2.5 times stronger than Earth's, Jupiter exerts a tremendous influence on its atmosphere. This gravity ensures that the planet retains its vast atmosphere, but it also creates instability in the environment. The strong gravity drives Jupiter's powerful winds and storms, including the Great Red Spot, which has been raging for centuries. These chaotic weather systems create constant turbulence, making it difficult for anything to remain stable within the atmosphere. Even more challenging, the immense gravity likely prevents the kind of slow, gradual evolution we see on Earth. On our planet, the presence of stable land and oceans has allowed life to diversify and develop over billions of years. In Jupiter's ever-shifting skies, such stability might be impossible to achieve. Hostile pressures, deadly radiation, a lack of carbon-based building blocks, and an unstable atmosphere. On the surface, these seem like insurmountable obstacles. And yet, we've seen life on Earth adapt to conditions we once thought were impossible. Could similar adaptations be happening in Jupiter's clouds? Or does life here rely on an entirely new set of rules, ones we've yet to discover? In the next segment, we'll dive into the anomalies and unsolved mysteries surrounding Jupiter's atmosphere. Could these be signs of something extraordinary hiding within those clouds? Now that we've examined the challenges of life in Jupiter's atmosphere, it's time to ask the big question. What if life has found a way to survive in this alien world? Could there be organisms suspended in Jupiter's dense, swirling clouds, riding the currents of its winds? To explore this tantalizing possibility, we'll draw analogies from life on Earth, delve into groundbreaking ideas like Carl Sagan's floaters and sinkers, and compare Jupiter to Venus, a planet that has also sparked theories of cloud-based life. To imagine life in Jupiter's clouds, we can look to surprising discoveries right here on Earth. Did you know that our planet's upper atmosphere hosts tiny, resilient life forms? Microbial life, including bacteria and fungi, has been detected in the Earth's stratosphere, floating at altitudes of up to 12 miles above the surface. These microorganisms survive in extreme conditions: freezing temperatures, low oxygen levels, and high exposure to ultraviolet radiation from the sun. They're carried aloft by wind currents, sustained by microscopic nutrients found in water droplets and atmospheric particles. If such life forms can thrive in Earth's atmosphere, it's not too far-fetched to consider the possibility of similar organisms living in the clouds of Jupiter. But unlike Earth's atmosphere, where microbes are temporary visitors, Jovian life would need to be permanent residents of the skies, never touching a surface or escaping the constant turbulence. To address this, scientists have proposed some fascinating ideas about how life could exist in Jupiter's atmosphere. One of the most famous concepts comes from the legendary Carl Sagan, who envisioned two types of potential life forms for gas giants: floaters, and sinkers. Floaters. These hypothetical organisms would be vast, balloon-like creatures capable of maintaining buoyancy in Jupiter's dense atmosphere. They might resemble massive jellyfish or balloons, using gas-filled chambers to keep themselves suspended at the right altitude within the habitable zone. They could drift through the clouds, absorbing energy from sunlight, chemical reactions, or lightning storms to sustain themselves. Sinkers. These would be smaller, denser organisms, possibly living deeper in the atmosphere where the pressure is higher. They might resemble the falling particles of organic materials seen in Earth's oceans, slowly drifting downward until they decompose or are consumed by other life forms. But what adaptations would these life forms need to survive? Buoyancy mechanisms would be crucial, allowing them to remain suspended in the atmosphere rather than being pulled deeper into the planet's crushing depths. They might also develop protective layers to shield themselves from radiation or acidic ammonia clouds. Another potential adaptation could be their ability to metabolize chemicals in the atmosphere. Just as some Earth microbes can survive by processing sulfur or methane, Jovian organisms might derive energy from the ammonia, hydrogen, or methane present in Jupiter's atmosphere. Such creatures could represent an entirely new form of life, one that doesn't rely on carbon-based molecules or water as we know it. Jupiter isn't the only planet to have sparked theories about cloud-based life. Venus, our scorching neighbor, has also been the focus of similar speculation. While Venus's surface is a hellish 900 degrees of, its upper atmosphere contains a temperate zone with Earth-like temperatures and pressures. In 2020, researchers discovered traces of phosphine gas in Venus's atmosphere, a chemical that, on Earth, is often produced by microbial life. Though the findings remain hotly debated, they've reignited interest in the possibility of life existing in Venus's clouds. Now, let's compare Venus and Jupiter. Both have zones in their atmospheres where conditions are relatively mild, but Venus's potential life would likely be microbial and tied to acidic water droplets. On Jupiter, the immense scale of its atmosphere raises the possibility of something more complex. Could organisms here have evolved into larger, more intricate forms like the floaters and sinkers imagined by Carl Sagan? While Venus provides a tantalizing hint that life can exist in clouds, Jupiter's size, energy sources, and diversity of chemical reactions could create an even more dynamic and varied ecosystem. The possibilities for aerial life in Jupiter's atmosphere are as awe-inspiring as they are mysterious. From microscopic floaters drifting on wind currents to vast balloon-like organisms harnessing the planet's energy, the idea of life in the clouds pushes the boundaries of our imagination. And with recent discoveries on Venus adding weight to the concept of cloud-based ecosystems, Jupiter remains a promising candidate in the search for extraterrestrial life. But what would it take to confirm these theories? In the next segment, we'll explore future missions and cutting-edge technologies that could one day reveal whether life is truly hiding in the clouds of Jupiter. If life is hiding in the clouds of Jupiter, how do we find it? The mysteries of this massive gas giant have captivated scientists for decades, and past missions have offered tantalizing glimpses into its secrets. But, as technology advances, new missions are on the horizon. Missions that could transform our understanding of Jupiter and perhaps even answer the question, are we alone in the universe? The story of Jupiter's exploration begins with some of humanity's most iconic spacecraft. In 1995, NASA's Galileo mission made history by deploying an atmospheric probe directly into Jupiter's thick clouds. This was the first and, so far, only time a spacecraft has sampled the planet's atmosphere up close. As it descended, Galileo's probe measured wind speeds of over 300 miles per hour and temperatures that soared to over 300 degrees Celsius before being crushed by the immense pressure. While it didn't detect evidence of life, it revealed key details about Jupiter's chemical composition, including the presence of water vapor and ammonia. These findings provided a foundation for later studies, showing that Jupiter's clouds are far more dynamic and complex than previously thought. Since then, missions like Voyager 1 and 2, Cassini, and Juno have given us incredible insights into Jupiter's atmosphere, magnetic field, and iconic storms. While these missions didn't directly search for life, they've helped build a roadmap for future exploration. Today, the search for extraterrestrial life around Jupiter is focusing on its icy moons, especially Europa, a world with a subsurface ocean that could harbor life beneath its frozen crust. 2 upcoming missions will study this moon and the Jovian system, with potential implications for understanding Jupiter's atmosphere. NASA's Europa Clipper, launching 2024. This mission will conduct detailed flybys of Europa to analyze its T2IG icy surface and search for signs of water plumes venting into space. While Europa is the primary target, the data gathered about Jupiter's environment, its radiation, gravitational forces, and chemical interactions could shed light on the planet's atmosphere and its potential for supporting life. ESA's JUICE mission, Jupiter Icy Moons Explorer, launching 2024. The European Space Agency's JUICE mission will focus on Ganymede, Callisto, and Europa. It will study how Jupiter's immense gravity and magnetic field influence its moons and the surrounding atmosphere. Though JUICE won't directly explore Jupiter's clouds, its findings could pave the way for future missions targeting the gas giant itself. As our technology evolves, new tools and missions are being developed to directly study Jupiter's atmosphere. Next generation telescopes. Ground-based telescopes like the Extremely Large Telescope, ELT, and space-based observatories like the James Webb Space Telescope, JWST, are poised to revolutionize our ability to study Jupiter's clouds from afar. These instruments can analyze the planet's atmosphere in unprecedented detail, searching for traces of water vapor, organic molecules, and other chemical signatures that might hint at life. Proposed missions to Jupiter's atmosphere. The idea of sending a dedicated mission to Jupiter's clouds has been gaining momentum in the scientific community. Concepts for future probes include spacecraft equipped with advanced atmospheric sensors capable of diving into the planet's habitable zone to search for organic molecules or even microscopic life forms. One proposed idea involves sending a float and collect mission, where a robotic probe could hover in Jupiter's atmosphere, sampling its gases and aerosols over an extended period. Such a mission would face immense engineering challenges, but it could provide direct evidence of whether life exists in Jupiter's skies, AI and autonomous systems. Advances in artificial intelligence and robotics are also making it possible to design smarter probes capable of navigating Jupiter's turbulent atmosphere and adapting to unpredictable conditions. These technologies might one day allow us to explore regions of Jupiter's clouds that were previously inaccessible. The missions of the past have given us a glimpse into the mysteries of Jupiter, while upcoming and future explorations hold the potential to unlock its greatest secrets. Whether through telescopes, orbiters, or daring atmospheric probes, each step brings us closer to answering the question, could life be hiding in Jupiter's clouds? The answers might be years or decades away, but one thing is certain. The search is only just beginning. And now, we turn to the climax of this journey. A shocking possibility that could redefine how we think about life in our solar system. Stay with us as we uncover the most dramatic revelations about Jupiter's skies. And now, for the most tantalizing possibility of all. If life exists in the clouds of Jupiter, it might be something truly alien. Not just different in form or appearance, but in its very essence, using survival mechanisms and chemical processes unlike anything we've ever encountered on Earth. Such a discovery wouldn't just expand our understanding of life, it would revolutionize the very concept of habitability in the universe. Recent strides in astrobiology have reshaped how we think about life and where it might exist. For much of human history, our definition of habitability was limited, focused on environments that resemble Earth. But discoveries in the past few decades have blown the doors wide open. On Earth, scientists have found life flourishing in hydrothermal vents at the bottom of the ocean, where sunlight never reaches. They've uncovered microorganisms living in toxic mine waste, thriving in arsenic-rich lakes, and enduring extreme radiation levels that would obliterate most life forms. These so-called extremophiles have proven that life is far more adaptable than we once imagined. Now, imagine applying that same logic to Jupiter. Could its alien environment foster an entirely new category of extremophile? One uniquely suited to the planet's chemical and physical extremes? Astrobiologists are beginning to entertain this idea with increasing seriousness. Finding life in Jupiter's clouds would fundamentally alter the way we approach the search for life in the cosmos. Up until now, much of our effort has been focused on planets and moons with liquid water and rocky surfaces, places like Mars, Europa, or Enceladus. But discovering life in Jupiter's atmosphere would prove that life doesn't need solid ground or even abundant liquid water to thrive. Such a discovery would force us to rethink our models of habitability. Here's why. Broadening the habitable zone. Traditionally, a planet's habitable zone is defined as the distance from its star where liquid water can exist. But if life can thrive in Jupiter's clouds, it would suggest that habitable environments might exist in the atmospheres of gas giants, exoplanets, and even rogue planets drifting through interstellar space. New biochemical pathways. Life on Earth is carbon-based, reliant on DNA and water to function. But Jovian life might be based on entirely different chemistry. For example, organisms in Jupiter's atmosphere might use ammonia as a solvent instead of water, or they might metabolize hydrogen and methane instead of oxygen. This would represent an entirely new branch on the tree of life, one that could exist independently of Earth's biology. Implications for extraterrestrial life elsewhere. If life can survive in Jupiter's extreme conditions, it vastly increases the likelihood that life exists elsewhere in the universe. With billions of gas giants in our galaxy alone, the possibilities become mind-boggling. Now imagine the first probe sent to Jupiter's clouds, equipped with instruments capable of detecting biological signatures. As it drifts through the turbulent skies, it collects microscopic samples, analyzing their chemical makeup and detecting anomalies. Unmistakable signs of life. What would these organisms look like? Could they glow in the darkness of Jupiter's storms, feeding on chemical reactions sparked by lightning? Could they have evolved over billions of years to use the dense atmosphere as a vast, unending ecosystem?